Okay, we are given three quite challenging trigonometric equations to solve. The methods to be used are different from one equation to other. They will not give you the same method to be used again and again. Another difference between the three equations is the domain. For the first two equations, the domain is given in radians, so your answer must be in radians. Whereas for the third equation, the domain is, for the first two is given in degrees, so your answer must be in degrees, whereas for the third one is given in radians, so your answer must be in radians. Let us focus at the first two equations. The first two equations involve the two trigonometric functions sin x and cos x. So one method to solve trigonometric equations is to bring the equation in terms of a single trigonometric function only. So I don't want to see both sine and cos. And now if I'm referring to my previous slide, with a formulae, what are the formulae joining the function sin y equals sin x and y equals cos x together? So these are the two relations we have. The first one I think is your normal formula booklet, the second one is not. Now, which one are we going to use? As we see in the first equation, sin x and cos x are both to the power of 1. So we cannot use this first equation, sin squared plus cos squared equals 1, because it will involve thirds. So I will choose to use the second one, trying to express all the variables in the equation in terms of tangent x, whereas for the second equation, the first formula is appropriate, because I can express cos square of y in terms of sin y. Okay, so dividing both sides by cos x, we get 4 tangent x equals 1, or tangent x equals a fourth. And now I need to look for all solutions in the domain between 0 and 360. One fact that students forget is that due to the periodicity, I can have more than one solution. So students would generally do x equals tan minus 1 of 1 over 4 and stop here. Is this the only solution? I need to think always of the graph of the y equals tangent x. Okay, here is a graph of y equals tangent x drawn in GeoGebra. Of course, you're not having GeoGebra in the exam, so you need to remember the shape of the graph. We know about the the vertical asymptotes as x equals pi over 2, okay, or 90 degrees, somewhere here. Okay, and the other one is x equals 270 degrees. I couldn't make GeoGebra to show me degrees on the x-axis, so on the x-axis we see radians. See pi radians is 3.14, so pi somewhere here. Okay, but of course I don't need it now. Right. Y equals tangent x. I want to see where tangent x equals a 4, so I need to draw y equals 1 over 4. Okay, which is here. Now, this one is y equals 1 over 4. Okay, where are the solutions of the equation tangent x equals 1 over 4? At the intersection point. So this will be one solution, this will be the second solution. Now, how do I get the values? Remember that your calculator, if you press tan minus 1 over 4th, will give you an answer only between minus 90 degrees and 90 degrees. So practically this one will be between minus 90 and 90 degrees. It will be that solution here. You need to be able to come up with a second solution by yourself, yes, using the periodicity of the tangent of the y equals tangent x function. Okay, I modeled this in GeoGebra. Have it here. Yeah, this one is the first solution. So if you press in your calculator tan minus 1 over 4th, it must give you, this point is labeled B, I think it must give you 0.24. Okay, just check. You need to take 3 significant figures. GeoGebra gives me 2 significant figures. Okay, how do we find the other solution? Okay, going back, I have just checked in my calculator. GeoGebra gives me the answers in radians, but you can set your calculator in degrees. So in degrees, this is going to be 14 point, okay, 0 degrees to 3 significant figures. So this one is in radians. You don't necessarily need to write radians. I need to give this answer in degrees. Now, how do I find the other solution? Okay, the other solution is at point C. We remember that our vertical asymptote, the first one is at, okay, x equals 90 degrees. Okay, the period of the function is 180. So practically, here is a point 180 degrees. Yeah, where the function starts to repeat, or pi, yeah, radians. That's why you see 3.14 there. So practically, the next point here will have the x coordinate. So C has an x coordinate 180 degrees plus 14 degrees to 3 significant figure. So your second answer will be 194 degrees to 3 significant figures. And here are your 2 answers. Okay, let us now look at the second question. The method used is different. We still have sine y and cos y in this case, but one of them is squared, cos square y. Therefore, we use cos square y is 1 minus sine square y. And we'll rewrite our equation 3 plus sine y equals 3 brackets 1 minus sine square y. At this point we stop and we analyze what we have. The unknown is in the form sine y and sine square y. So I'll just say let sine y be t. And I'll change it into a quadratic equation. 3 plus t equals 3 brackets 1 minus t squared. Okay, this quadratic equation changes into 3 brackets 3t plus 1 equals 0, which is going to lead us to the solutions t equals 0 or t equals minus a third. Now let us remember that our t was sine y, that we are looking for solutions between 0 and 360 degrees. Again, we can refer at either the graph of y equals sine t. I see many of you prefer the graph. We start from sine 0 equals 0 between 0 degrees and 360 degrees. Or I prefer to look at the trigonometric circle. Both methods are correct. So, where do we have sine y equals 0? Here is one solution, here is one solution, here is one solution. Oh, 0 and 360 are not included in the domain, so my only solution will be y equals 180 degrees from the first equation. If I look to the trigonometric circle between 0 and 360, where is sinus 0? Sinus is the y coordinate, so it's going to be 0 here, here, or again at 360. That is not in the domain, so only these ones are the solutions for sine y equals 0. Now we need to look at the solutions for sine y equals minus a third. So sine y equals minus a third. Suppose minus a third is here, not to scale. So we'll see that we have 2 solutions. Okay? On my unit circle, this is sine, so minus a third. So I have 2 angles, one is here, one is here. Now in order to start with something, we'll press y equals sine minus 1 of minus a third, and my calculator gives y equals negative 19.5 degrees. Okay, as you can see, this point is not in the domain, so it's going to be somewhere here, this point here. How am I going from this point to my points, the 2 points that I need? Okay, if I look at the graph, because the distance between these 2 points is 180 degrees, and the distance from here to here is 19.5, yes, it means that this distance will be 19.5 as well. So practically one of the answers is y equals 180 degrees plus 19.5 degrees. That's the first answer. If I look in the I'm just trying to give you two different methods. If I look at the unit circle and I start from 0, this one is negative 19.5, but I need to go in the positive direction to find my first solution. So I'm going to go 180 degrees plus 19.5 degrees, same answer. How do I find the second solution? Okay, for the second solution, the distance from 0 up to here is 360. Yeah, so the second solution is going to be 360 degrees minus 19.5 degrees. Same on my unit circle. I start from 0, so I go 360 degrees and back minus 19.5 degrees to reach the same point. Okay, so we're looking now at another type of trigonometric equation. Sec z over 3 equals 4. I always try to get back to the basic trigonometric functions, which for me are y equals sin x, y equals cos x, y equals tan x. So let us write then sec of z over 3 as 1 over cos z over 3 equals 4. Therefore, cos z over 3 equals 1 over 4. So we will let, let z over 3 be t. The challenge here is to realize that your equation changes into cos t equals 1 over 4. But where are you looking for the solution? Where t is. So if z is between 0 and 5, z over 3, which is t, will be between 0 and 5 over 3 radians. Set your calculator in radians and you try to find t, which is cos minus 1 negative, inverse cos of a fourth. Set your calculator again in radians and you get 1.32. Oh, we see that we are very close to 5 over 3. So if I'm thinking of the unit circle, where you can draw your graph, yes, your angle is going to be somewhere here. Pi is 3.14. This one is less than pi, so that would be your angle. Yes. Then another angle with the same cos is going to be here, so it's too big to be a solution. Therefore, my solution is z equals 3t. So z equals my only solution 3 times 1.32. 3 significant figures. Again, as you saw, 3 different questions, different approaches. The method for the first question is use tan, write everything in terms of tan. The method for the second, just because cos of y was squared, was using sine square y plus cos square y equals 1 and changing it into a quadratic equation. And the method for the second one The third one was actually a standard question, except for the fact that you need to be careful about the domain. So because it's not x or z and it's z over 3, yes, this represents an horizontal stretch by a factor of 3, therefore the domain stretches as well. So you need to be careful where to look for solutions for this type of equations.